Hey everyone, welcome back. Ready to dive into a topic that's totally blossomed in the world of science.
Sunflowers. I bet you've seen them around but never realized they're like mathematical masterpieces.
Seriously though, today we're diving into your research, and let me tell you, it goes way beyond just pretty petals. We're talking about the famous Fibonacci sequence, right?
You got it, that mathematical wonder that seems to pop up in the most unexpected places.
And we're going to unpack it all. So, quick recap for anyone who needs a little refresher. The Fibonacci sequence, it's where each number is like the sum of the two before it. So we're talking 0, 1, 1, 2, 3, 5, 8, and so on. But what's the big deal with sunflowers and this sequence?
Well, it's all in the arrangement of their seeds. See
Mhm.
those spirals? That pattern, it's called phyllotaxis, and it's not random at all.
Hold on, philo what now?
Phyllotaxis, it's a mouthful, I know. Basically, it describes how those seeds are arranged. And the Fibonacci sequence, it creates this spiral that allows the sunflower to cram in as many seeds as possible.
Okay, so it's like a space-saving strategy for the sunflower, getting the most out of that flower power.
Exactly. More seeds, more chances to soak up the sun, and more chances for those sunflowers to thrive. It's all about efficiency in nature.
And didn't I hear something about a special hormone involved in all this too? Something with an A?
Auxin. You got it. It's a plant hormone that plays a key role in how that sunflower actually grows. Like a conductor, guiding those seeds into that perfect spiral formation.
So there's a whole hidden dance happening within the sunflower, orchestrated by this auxin. This is blowing my mind already. And speaking of amazing things, we can't forget about the other big mathematical star of the show, the golden ratio. It's like the Fibonacci sequence's celebrity cousin.
You know it, and they're definitely related. See, this golden ratio, about 1.618, it pops up when you look at the proportions within that Fibonacci spiral.
Wait, slow down a sec. I need to catch up. So you're saying this golden ratio, it's like a secret formula for beauty.
You could say that. It creates these visually harmonious proportions that are pleasing to the eye. And guess what? It's not just in sunflowers. Think art, think architecture. The Greeks, they were all over this. Look at the Parthenon. It's the golden ratio in action.
So we're saying sunflowers are basically walking, talking works of art, following this ancient mathematical rule.
Pretty much. And get this, it's not just about looks. The golden ratio's in the structure of the sunflower, helping it stand tall and catch the most sunlight. Now that's efficient design.
Amazing. Sunflowers are officially way cooler than I ever thought. But you mentioned something earlier about how this research, it goes beyond just plants, right?
Yeah, it goes way beyond. And this is where things get really wild. We're talking about applying this knowledge to things like, get this, financial models.
Hold up. Are you serious? Sunflowers and money matters. How on earth is that connected?
It's all about those underlying mathematical principles. You see, in finance, you've got this thing called present value analysis. It's all about figuring out the value of something over time. And those core ideas, they share some surprising similarities with how that sunflower arranges its seeds for maximum growth.
Whoa, I never saw that one coming. So the same math that makes a sunflower so efficient, it's being used to understand the world of finance. That's wild.
And this isn't new. We're talking about a sequence that's been around for centuries. This whole thing started way back in 1202 when a guy named Leonardo of Pisa, also known as Fibonacci, introduced it to the Western world. Since then, it's been blowing minds, not just in math, but in botany, art, you name it.
All right, now we're talking about art. This deep dive is full of surprises. I thought we were talking about sunflowers.
Oh, that's the beauty of it all. Think about it. Art often tries to capture the beauty we see in nature, right? And that golden ratio, it's been called the epitome of perfect proportions. So it's no surprise that artists throughout history have stuck it into their work.
Get out of here. So some of the world's most famous paintings and sculptures, they have this secret sunflower code embedded in them.
You got it. Take Leonardo da Vinci, for example. His Mona Lisa, it's full of golden ratio proportions. Michelangelo's sculptures, same thing. These guys, they understood the power of this ratio and used it to create some of the most stunning works of art in history.
This is mind-blowing stuff. And to think it all started with a simple sunflower. Who knew?
That's the beauty of knowledge, right? It's like one discovery leads to another, and before you know it, you've gone down this rabbit hole of incredible connections. And we're not even done yet.
You're kidding. There's more.
Oh yeah, we're just getting started.
Yeah.
We've got a lot more ground to cover. Trust me, this deep dive is about to get even more fascinating.
I'm hooked. Tell me more.
Okay, but buckle up, because we're about to go deeper into the sunflower secrets.
Bring it on. I'm ready for more.
All right, so we've talked about the beauty, the math, the art. But there's a whole other level. We're talking about the future of this research. Imagine unlocking the genetic secrets behind these sunflower patterns.
Wait, are you saying we could actually manipulate those patterns? Like make a sunflower with, I don't know, a smiley face seed arrangement?
Huh. Well, maybe not a smiley face. But seriously, imagine the possibilities. If we can crack that genetic code, we could boost crop yields, develop... The sky's the limit.
That's incredible. We could revolutionize agriculture. And hey, maybe even inspire a whole new wave of art and design based on these natural patterns, right?
Exactly. It's like opening the door to a whole new world of possibilities. And to think, it all started with that simple question. What's up with those sunflower spirals?
It's amazing how one question can lead to so many more. Speaking of questions, something's been on my mind throughout this whole deep dive.
Shoot. What's got you thinking?
Well, we've covered so much ground: math, science, art, even finance. But out of all of it, what fascinates you the most about these sunflower secrets?
That's a tough one. There's just so much to be amazed by. But if I had to pick one thing, it's the sheer elegance of it all. You know, the Fibonacci sequence, it's so simple,
Hmm.
yet it creates these incredibly intricate patterns. It's like nature's showing off its artistic side while also being incredibly efficient.
Right. It's like nature's way of saying, I can be beautiful and strategic at the same time.
Exactly. And the fact that we can use math to understand these patterns, it's like we're decoding nature's language. It makes you realize that there's so much more to the world than meets the eye.
It's both humbling and incredibly exciting at the same time. It's like, who knows what other mysteries are hiding in plain sight, just waiting for us to uncover them.
Now you're getting it. That's what makes this whole field of study so captivating. There's always something new to discover, some new connection to make. And who knows? The next big scientific breakthrough might come from observing something as seemingly ordinary as a sunflower.
I love that. Okay, before we get too far ahead of ourselves, let's bring it back to the sunflower for a minute. We've talked about the science, the math, even the art. But what about the cultural significance? Have sunflowers always held this kind of fascination for people?
Oh, absolutely. The Fibonacci sequence, it's like a universal language. It pops up in ancient mythology, religious symbolism, even modern pop culture. It's a story that people have been drawn to for centuries.
So it's more than just a mathematical formula. It's a symbol, something that speaks to us on a deeper level.
Exactly. It represents this order, this interconnectedness that we see throughout the universe.
Hmm.
And because it's present in everything from sunflowers to galaxies to even the human body, it reminds us that we're all part of something much bigger than ourselves.
I love that. It's like a reminder that we're all connected by these invisible threads of math and nature.
Right. It's a beautiful thought.
It really is. Well, I have to say, this deep dive has been incredible so far.
Agreed. It's been a pleasure exploring these ideas with you.
You know, it's one thing to talk about all this amazing research and these mind-blowing theories.
But there's nothing quite like seeing it all play out in real life, right?
Exactly. So let's shift gears a bit and talk about actually observing these patterns in nature. Have researchers been able to confirm all this Fibonacci magic in real sunflowers?
Oh, absolutely. Scientists, they love to put theories to the test, you know. And in this case, it's all about getting up close and personal with those sunflowers.
So we're talking about researchers armed with notebooks and magnifying glasses, meticulously counting spirals and measuring those angles.
You got it. It's pretty amazing, actually. They go out there, count those spirals, and guess what? More often than not, those numbers they come up with, they're Fibonacci numbers.
It's like nature is speaking in this secret mathematical language, and these scientists are cracking the code.
That's a great way to put it. But here's the thing about nature. It's full of surprises. While most sunflowers follow the Fibonacci spiral beautifully, you'll always find a few rebels out there.
Rebels, what do you mean?
Well, some sunflowers might have a slightly different number of spirals than expected, or maybe the arrangement is a bit off. It could be due to environmental factors, maybe some genetic quirk. Nature loves to throw in a little variation.
So it's not always picture perfect.
Exactly. And that's what makes studying the natural world so fascinating. It keeps us on our toes, reminds us that we don't have it all figured out. There's always something new to discover, some new twist in the tale.
I love that. It's like each sunflower has its own unique story to tell.
Exactly. And those little variations, those quirks, they hold valuable clues about how genes, the environment, even random chance all come together to shape the incredible diversity we see in nature. It's a never-ending puzzle, and I, for one, am completely hooked.
Me too. And you know, after this deep dive, I don't think I'll ever look at a sunflower the same way again.
Me neither. It's amazing what a little curiosity can uncover.
It really is. And for our listeners who are now just as captivated by these sunflower secrets as we are, we've got a ton of great resources linked in the show notes. You can keep exploring these fascinating concepts and dive deeper into the world of Fibonacci.
Don't be afraid to get your hands dirty. Do some exploring of your own, and who knows, maybe you'll be the one to uncover the next big sunflower secret.
That's a challenge I can get behind. And on that note, we'll wrap up this incredible journey into the heart of the sunflower.
Until next time, keep those minds curious.
And remember, there's always more to discover.